Hi guys, it's Miss Miller. I was just going to record a video for you all to start understanding and kind of clarify some things that I'm getting a lot of questions about as far as probability notes. So this was kind of the best way that I could come up with to be able to share these with you. So right now you should be able to see my screen and I just made these probability notes. If you want to print these off, feel free. But I'm just going to kind of walk through them and just use my cursor as kind of my pointer. I think, oh, look at all these fancy things. I can do a pen. Oh, and I can make it pink. Oh, watch out, world. So I'm going to do probability notes. Oh, yes. Watch out, world. Okay, so right now I am doing just very, very basic at the very beginning of what's going on. So I am right here when you see probability, it'll say P of whatever that is. This is called the event. And the way you read this is probability of. So if we were talking about a die, which is the singular form of dice, dice means multiple, die means one. So I'm not telling you to go die, relax. You are going to set it up as a fraction. So the numerator right here is going to tell you that this is the true event. This fits exactly what it's asking you for, this probability of whatever. Then 6 is the sample space. So when you list all of the possibilities of what's going on in rolling a die, all of those possibilities, your sample space would look like this: 1, 2, 3, 4, 5, 6. Okay, that's all of your total possibilities. So there's 6 options. And if we were trying to solve for the probability of rolling an even number, we would count all of the true possibilities from when we rolled our die. So all of the possibilities that make this true are 2, 4, and 6 out of a total of 6. Okay, this is basic, basic, basic probability. The way we show this in a probability tree is by telling this is the event that's happening, and these are all of our options. So we can roll a 1, we can roll a 2, we can roll a 3, et cetera, et cetera. Okay, this is how you can list out the sample space. This is what's going on and showing all of the possible different events. Okay, so now we're getting a little bit harder. Now we're talking compound probability. This is where I think a bunch of people are getting confused. So that's why I really wanted to go through and clarify what's going on here. So our first example here is the probability of 3 and a 5. So that means we're rolling 2 different times. Those are separate events. They do not affect each other. They are independent, okay? So when we're talking about the word and, it means we're going to take each of those individual probabilities, the probability of rolling a 3 and the probability of rolling a 5, and we're going to multiply their probability. So when we see the word and, we're going to multiply. So we're doing 1/6 times 1/6, which equals 1/36. So this is saying this has to be the one order because it's 3, then 5. Okay, so there's only one way to do that. That's our overall probability of rolling a 3 and then a 5. Okay. Next example is if you are given 2 options. And it's okay for you to take either one of those, like to win a game or something. You have to roll either a 3 or a 5. This is you're only rolling one time, so it's one event. Okay. So in that case, we take each of the individual probabilities right here: 3, which is 1/6, and 5, which is 1/6. They're totally independent of each other, and we add them up to get 2/6, which is the probability 1/3 that we're going to get this true event. Okay. So then we go down to something where it's generalized and we have to make it more specific. So if it said probability of an even number, like what we did at first, we could do the probability of 2 or 4 or 6. So we're going to take each of these independent probabilities and add them up. 1/6 plus 1/6 plus 1/6 is 3/6, which ends up being 1/2. Okay, so that's our final answer here. To show multiple rolls, what we have to do, like when we did earlier, how we looked at when it said 3 and 5, this talked about 3, then 5. If we're talking about either way, a 3 and a 5 or a 5 and a 3, you would basically do this twice, okay? Because it's telling you the probability of 3 and 5 or adding the probability of 5 and 3. So what I did is I made a probability tree right here. And this is telling me that I did 2 rolls. Here's my die. When I rolled it, I had 6 options every time. Okay, so I could have gotten a 1. This shows me my first roll, the results 1, 2, 3, 4, 5. I listed out every possibility. Then, if I got a 1, then on my second roll, I could have gotten a 1, a 2, a 3, 4, 5, or 6. Same with if on my first roll I got a 2, I could have gotten a 1, 2, 3, 4, 5, or 6. Okay, so all of these are telling you all of the different possible pathways that you could have come up with. So you could have rolled a 1 1, a 1 2, a 1 3, a 1 4, 1 5, 1 6, etc. Okay. This probability is asking you about 3 and 5 together. Okay. So there's only two pathways where it goes a 3 and a 5 right here. So that's one. Or it can go 5 and 3. That's another one. So we take the probability of 3 and 5 and the probability of 5 and 3 and add them up to get 2/36. Okay. This is the difference between the order. That's what changes here. There are two true events. So we have to show that order. Order matters. Okay, this is the last thing that I want to get into today before we finish up, and it's called compound probability. This is when you have something that there's a replacement, okay? This is when there's some overlap that goes on. So, like if we were finding the probability of a jack, it would be 4 out of 52 total cards. If we're talking about a standard deck of cards. Then, if we get another problem that said probability of a jack or a red, individually they have two different probabilities. So, jack is 4 out of 52 cards, and a red card is 26 out of 52 cards. But since both of those make it true, we have to subtract out the overlap. Okay. So we're counting it twice because we have 4 jacks over here: a jack of spades, jack of clubs, jack of hearts, and jack of diamonds. And then we have all 13 diamonds and all 13 hearts. So we have to subtract that jack of hearts and that jack of diamonds, which is counted twice here. So our ending probability is 28 over 52. And you can just leave it like that. You don't have to reduce it. There's a couple times where in Khan Academy it has you do the decimal version. Just divide them. That's why we worked so hard on fractions, decimals, and percents beforehand, so that when we got to this, that you would understand what's going on. Now, I know that I talk fast, and I know that you are going to have a lot of questions. The big thing with compound probability that you need to know is, do these events affect each other? And if it says either or, you're going to add their individual probabilities. And if it says and their probability of doing both, that's talking about two events, and you have to multiply their probabilities. Okay. If you have questions, please, please, please message me. My life is crazy right now, and I'm so, so sorry. First grade online is hard. In case any of you were ever questioning trying to go back and do first grade right now, because don't do it because it's so hard. Love you all.